Okay, here's a lesson on how to find zeros of a polynomial. I'm going to show both methods that I think you guys need to be ready for. Either the polynomial is going to be given to you and easily be factorable, or you will have to apply the rational zeros theorem to help you find possible x-intercepts that will help you break down the polynomial in order to find those zeros. So let's start off with f of x equals negative 17x cubed plus 5x squared plus 34x minus 10. So we check first to see if greatest common factor is found between these four terms. And as of now, there isn't anything other than positive 1. So that's not going to help us. But we do see that there are four terms. So we always try to attempt to see if factoring by grouping would work out. So let's see. We'll look at the first two terms and pull out the greatest common factor. In this case, between negative 17x cubed and 5x squared, we know that there will be a 1 as far as GCF in the coefficients. The variables, it will be an x squared. And so we always take the sign of the first term. So we are going to take a negative 1x squared or negative x squared out of those two. And between these two, between 34 and 10, there's a 2, and then it's just going to be a 2 because they don't both have x's. The sign is a positive for the first term, so we're going to take out a positive 2 out of the next group. So let's start factoring by grouping. So here we go. We pulled out a negative 1x squared, so negative x squared. Divide those both by negative x squared, and we'll get a 17x minus a 5. This divided by this, and this divided by this gives me this. I'm going to write the other GCF. And once you divide those two, you will notice you get also 17x minus 5. We always hope to see that both of these are identical, which in this case they were. And we'll write the GCF in one set of parentheses. That will become one factor. And the other factor was 17x minus 5, which was the greatest common factor for this entire expression. So this is easily to set equal to 0 and solve for x. Right here, we see something's going on here. It's not really a difference of squares, but if I did pull out a negative, I can force it to become a factor of difference of squares, where I can use that property that we initially learned about difference of squares. If you don't remember what I'm going to do it over here at the side, remember if you have a difference of squares, a squared minus b squared, it can be easily factored to be a plus b times a minus b. So we're going to take advantage of that and do that for this factor. Okay, so I know this is not a perfect square, but I could still use this property to help me factor. So I'm going to bring down that negative. Again, I know there's going to be a plus minus situation. This is just going to come down here. And notice that when you apply difference of squares, all you're doing is square rooting a and b and putting those answers right there and making sure one factor has a plus and the other one has a minus. So I'm going to square root a squared and b squared. So the square root of x squared is an x plus, and then I'm going to put an x and a minus. And the square root of 2 would be a decimal. So I'm just going to leave it in irrational form as square root of 2. Okay? Now it's fully factored in linear form. In other words, every x is raised to the first power. So all I need to do is apply the zero product property for each one of these cases. And when I set them each equal to 0 and I solve for each x, I would get these answers. So we have 3 roots, and it matches up with the fact that our polynomial degree was 3. Therefore, we should end up with 3 roots. So that's where the polynomial is intersecting the x-axis at those 3 points, those 3 x-intercepts. So here's another example. Let me write that out. Let's start up here. Let's call this one g of x. G of x equals 3x cubed minus 13x squared plus 43x minus 13. So notice I've given you another situation that is a polynomial of 4 terms, but notice that you are unable to factor this at all, okay? 3 and 13 do not have a GCF other than 1. They do have a GCF here of x squared, but notice if you pull out a GCF here, which is only 1, the remaining factor is not going to be the same as this one. So grouping is not going to work at all. So here's where you use what's called the rational zeros theorem, okay? And the rational zeros theorem helps us to find all possible scenarios as far as zeros go that can possibly be x-intercepts for our polynomial. So the rational zeros theorem, let me write this out, is going to help us do that. So what you are going to do when this happens is you are going to look at the leading coefficient. Okay, remember the leading coefficient is the term that has the degree in it, okay? And then I want you to look for the constant of your polynomial. And if your polynomial is written in standard form, it'll always be the first and last, but please make sure your polynomial is written in standard form from highest to lowest exponent. And these play a role in helping you determine what those x-intercepts are possibly going to be, okay? Because, you know, we can't use the calculator. So here is the rule. You are supposed to find all the factors of a sub n, and you have to divide them by all the factors a sub 0. So you're asking what is a sub n and what is a sub 0? Well, a sub n is this, whoops, hold on. It's this one right here. I always want to say it's the first one. And a sub 0 is going to be this one. Now, what you're going to do, no, I do have it backwards, don't I? Hold on. Ignore me. A sub n is this one. And a sub 0 is this one. All right. So, what you're going to do is going to take your factors of a sub n, and you are going to divide them by the factors of a sub 0. So the factors of a sub n are going to be, for this, a positive and a negative 1, and a positive and negative 13. And I'm going to divide those by the factors of a sub 0. Oh my goodness gracious. Hold on. The factors, I have this backwards too, don't I? I think this is a sub 0. This is a sub n. The factors of a sub n, which is plus minus 1 and plus minus 3. I'm making a mess out of this. Okay, now that I've confused you enough. Anyway, so what you're going to do now is take these factors and divide them into these, okay? And when I say factors is the numbers that are all divisible by whatever the number is. So a sub 0 in this case was our negative 13 up here, and a sub n was our 3. So you're listing all the factors of this and this, okay? And what you do is take each one of those and divide it by each one of those. I need to take plus minus 1 and divide it by plus minus 1. Well, 1 divided by 1 is just 1. So one answer is plus minus 1. Then I take this one. This I need to divide it by this. Now this divided by this. Well, 1 divided by 3 is just 1/3. So I'm just going to leave it as plus 1/3. Then I'm going to repeat the process for this. Take this and divide it by this, and this divided by this. 13 divided by 1 is just 13. So I'm going to put plus minus 13. And this divided by this, 13 divided by 3 is going to be 13/3. And I write it in fraction form because it would be a decimal, and I prefer fractions. So now what you're going to do is merely guess and see which one do you think of these 1, 2, 3, 4, 5, 6, 7, 8 possible zeros is actually a zero of this polynomial. In other words, if this graph was graphed, which one of these would be where the graph crosses the x-axis? So you can only guess, again, because we don't have a calculator. So for instance, I'm just going to try +1, okay? So I'm going to put a 1. I'm going to do this by using synthetic division because it's just the fastest method. I'm going to write my 0 here, and I'm just guessing, okay? This is pure guessing. You could have chosen whichever one you want. So 1 is which one I chose, and then I'm going to write down all the coefficients. So I have a 3, a -13, a 43, and a -13. Bring that down. 1 times 3. Add -13 and 3 is a -10. 1 times -10 is -10. Add vertically, so that's going to be a 33. 1 times 33 is a 33. Add, and my remainder was a 20. This was not a 0 remainder, so x equals 1 is not going to work for us. Okay, that's not an answer. I know which is the answer, so I'm just going to go ahead and give you the 0 that actually works. You will keep guessing, okay? But just for purposes of not wasting time, once you keep going, if you'd done -1 next, -1 would have worked. The next one was 1/3, or you can jump around. It's up to you. Repeat the definition, the synthetic division. Again, you're hoping this one would end up in 0. So I'm going to bring this down. 1/3 times 3, well, that's a 1. -13 and 1 is a -12. 1/3 times -12 is a -4. 43 minus 4 is a 39. 1/3 times 39 is a 13. -13 and a 13 makes a 0. And we are super happy, okay? Because that's the whole point. We want to have a remainder of 0 because what we've done is prove that 1/3 is a 0 of this polynomial, okay? So if this worked, that means g of x, where is it? G of x right here is equal to this right here, okay? So here's the thing. We know x equals 1/3, but I want to write it in a factor form. So that 3 multiplies, and whoops, you can't see what I'm writing. That 3, okay, so this 1/3 worked, so I wrote x equals 1/3, but I want to write that in factored form, okay? So this 3 is dividing, it's underneath the division, is going to come over and become a 3x. And that 1 is a positive 1. When I move it over, it's going to become a -1. So 3x minus 1 is this x-intercept. And it makes sense because if I set this equal to 0, I have to add 1, divide by 3, and I'll end up right back there. Okay? So this belongs to what I just found there. And then this goes in here. This 3 comes down. I know there's an x. The x is going to be the degree that was 1 less than this. And this came from here, which is x cubed. So that means this one has to be x squared. And then minus 12 has to be 1 less than this. And then 39 goes here. And you keep factoring. So you look at this and you're like, okay, can I factor that? Well, lucky for us, we can see that these are all divisible by 3. So I'm going to pull a 3 out of all these right here, okay? And I'm going to pull a 3 out, and I'm going to put it way at the beginning. So I'm going to put a 3 right here. This is just going to come on down. And this is going to be divided by 3, so you're left with x squared minus 4x and another 13. And then you ask yourself again, okay, well, can I factor x squared minus 4x plus 13? Are there two numbers that multiply to be 13 that add to be -4? Well, there isn't any, because 1 times 13 is 13, but they add to be 14, and -1 times -13 is 13, but they add to be -15. There aren't any. So what do we do when we cannot factor a quadratic? It's a quadratic because the exponent is a 2. Well, we go and use the quadratic formula. Okay, we use the quadratic formula. And so if you apply the quadratic formula, okay, and work it all out, I'm going to save you the time there as well. You're going to, actually, let me go back over here. You will come out and realize that the x's you get were going to be a 2 plus minus a 3i, okay? That's what the x's were going to be. Notice that these are imaginary numbers, complex numbers, right? They always appear in pairs. And it makes sense because notice that our degree was a degree of 3. We had to find 3 zeros. So either our zeros were going to be all real numbers, all 3, or they were going to end up being one real and a pair of complex numbers, because they always have to be a pair. So 1, 2, and then the 3 that we found from right here. So to write these in factored form, okay, this 3 comes down, this came from this, so it's 3x minus 1. And then I have 2 of them over here, so I can write it as x minus, and then 1 is 2 plus 3i. And then I'm going to write it over here because I don't have enough space, or x minus, open parentheses, 2 minus 3i. Okay, so always notice that it's always going to be a minus. It's always going to be a minus, okay? So 1, 2, 3 factors. And again, if you wanted to list your zeros, you would have a 1/3, and then you would have a 2 plus minus 3i. So here it is written as far as what are the zeros. The zeros are going to be a 1/3, a 2 plus 3i, 1, 2, 3. If you want to write it in factored form, it's going to be 3 times 3x minus 1 times x minus 2 plus 3i times x minus 2 minus 3i. And that's it.